morning, students. Today we will do our second video on GATE Physics 2020, the questions we have left. So starting with the question number 13. Question number 13 says that which one of the following relations determines the manner in which the electric field lines are reflected across the interface between two dielectric media having dielectric constants epsilon 1 and epsilon 2. Okay, so to perform this type of questions, there is you can say a trick or a solution is basically we have to perform a I can tell you that, see, if you can see this is normal, this is normal, this is normal. Okay, so and this is your plane, and this is your plane. Okay, so now electric field travels from one surface one that your surface epsilon 1 to your one dielectric constant from epsilon 1 to epsilon 2. Okay, so now the angle is made from normal, the angle is made from normal. So whenever is made from normal, then the formula is tan theta 1 upon tan theta 2 is equal to epsilon 1 upon epsilon 2. Okay, so this is the formula. So now when you will transform when you will multiply it like this, e2 tan theta 1 is equal to e1 tan theta 2. So now you can see this, that the answer is this, epsilon 2 tan theta 1 is equal to epsilon 1 tan theta 2. But in options, none of the answer matches this. So we can perform one more step. We can convert tan theta 1 to cot theta 1 is equal to epsilon 1 upon cot theta 2. Okay, so when I will transform this, it will become e2 cot theta 1 is equal to e1 cot theta 2. Okay, so what it will become? It will become e epsilon naught 2 cot theta 2 is equal to epsilon 1 cot theta 1. So the answer is your D. But don't confuse with the concept. Concept is same, that if the angle is made from the normal, then it is tan theta 1 upon tan theta 2 is equal to epsilon 1 divided by epsilon 2. Okay, but if in any other entrance exam or in future it gives the angle is made with the surface, angle is made with the surface, angle is made with the surface, this is the surface. Okay, this plane is your surface. So then what will be the formula? Then formula will be cot theta 1 cot theta 2 is equal to epsilon 1 upon epsilon 2. Don't confuse this formula with this. This we have calculated, answer is this. Don't confuse with this. We have to match the answer with the given options. We have changed here tan theta to cot theta. But if the angle is made from the plane, from the surface, then formula is cot theta 1 by cot theta 2 is equal to epsilon 1 by epsilon 2. Okay, so this we have to take care of. Now see, this is not a difficult problem, but this is a tricky problem. Okay, but this is a tricky problem. But one thing you have to remember is that you have to go for the basic you have learned, not for not for the trick it wants, but go for the basic. Then you can change the answer, or you can match the answer with the given options by changing tan theta to cot theta. So now our next question is question number 17. Particle A with angular momentum J is equal to 3 by 2 decays into two particles. So where we have one particle, we have one particle, that is A, it decays into B plus C. So A has angular momentum J 3 by 2. So it has angular momentum J is equal to 3 by 2, and we have given the angular momentum. See, first this is your J, this is your J, okay, this is your J. Now what it has given, this is your M, total M. You know that there is angular quantum numbers, n is equal to principal quantum number, l is equal to orbital quantum number, ml is your magnetic orbital quantum number. So this is your total M, because see, when you take I give an example that when you take two particles, that is your J1 is equal to 1 or J2 is equal to half. So what will be the total J? Total J will be 3 by 2 and 1 by 2. 3 by 2 and 1 by 2. So now if I take the M for this, M for this one M, I can mark it here, this M, you can take M is equal to 3 by 2, 1 by 2 minus 1 by 2 minus 3 by 2. This is your total M. For this, total M is equal to half and minus half. So M goes to minus J2 plus J. M goes to minus J2 plus J, or J2 minus J. Okay, so this is your concept. Okay, so this is your see what it has given. It has given your J, this is J. Okay, this is total M, and what is this? This is J1, and this is M1, and this is J2, this is M2. Okay, so total J is equal to J1 plus J2. So it is coming 1 plus half, you will get 3 by 2. For M1, 1 plus half, you will get 3 by 2. So now see, this is the question of Clash Gordon coefficient, CG coefficient. CG coefficient is mainly CG coefficient is used to describe the addition of the angular momentum. Is used to describe the addition of angular momentum. Addition of angular momentum. Okay, so now, but see, this question is very, if actually there is a very deep concept also, and you have to practice a lot for this type of questions. I will because if I try to explain here CG coefficient, it will take 2 to 3 video lectures, and it is totally step by step, and you have to perform step by step, and then you can get the additions and the constant terms with the respective when you add two spins. But see, here it is not possible to describe whole steps. So here I'm only describing the solution, the particular solution of this. On my later videos in coming future, I will describe CG coefficient in detail, but here you have to take it as granted if you don't know about the concept in detail. So I'm sorry, I cannot explain in this time. So now what you have to do for the solution, now you know J1 is equal to J1 plus J2 and M is equal to M1 plus M2. So we have given A decays to B plus C. So now what you can do, how can you guess what is alpha? What is alpha? Alpha actually, what is meaning of alpha here? I have told you in quantum mechanics, when we do the expansion, we get C1 phi 1 plus C2 phi 2. So here C1 C2 corresponds to alpha. Okay, so what you mean, and I also told you that C1 square plus C2 mod square, okay, this goes to is equal to 1, so it should go to 1. First concept is this. Okay, now uh, actually I have to explain from beginning, but because due to the time constraint I cannot explain whole. So what we can do here is, now you have to remember this, that we can write this like this is be the coupled equation 3 by 2 comma 3 by 2. Okay, now psi 1/2 1/2, we can do this. So this now you become J1 J2, this your becomes M1 M2. So this is your J, this is your M. So J1 plus J2 will become 1 plus half 3 by 2, and M is equal to M1 plus M2. So now you can easily guess this will become 1. So alpha is equal to 1. Okay, I have done the best here to explain this CG coefficient, but it will take 2 to 3 videos to describe this. So this is your solution. So now this what now the next sum, hydrogenic atom is subjected to a strong magnetic field. There is a strong magnetic field. In the absence of spin orbit coupling, the number of doubly degenerate states created out of the d level is. So you have to tell that how many states. So answer to this is, see, it is atomic molecular physics question. So what is strong magnetic field? What is strong magnetic field? Strong magnetic field is when there is Paschen-Beck effect. There is Paschen-Beck effect, and you know should know because see here I will not discuss the difference between the your Zeeman effect and Paschen-Beck effect. In atomic molecular physics videos we will discuss in detail this one, but here I can tell you the concept of this particular question. Now see, this there is a hydrogenic atom, okay, and you are asking when it is put in strong magnetic field, and then what happened to the d level, that is what is the number of doubly degenerate states created out of the d level. So you know, so you should know the basic concept that what is L. L is equal to 0 1 comma 2 comma 3 up to so on, and first denote s orbital, then it is p orbital, then it is d orbital. So L is equal to 2. So what is ml here? Ml is equal to minus L2L, so it will go minus 2 minus 1 0 1 comma 2. Okay, so this is the your ml. Okay, now what you can do, now for this is hydrogenic atom, so L is equal to 2 here. Obviously spin should be half. Obviously spin should be half. Okay, so now how the splitting is splitting level is calculated. Splitting level is calculated splitting level is equal to 2L plus 1 2s plus 1. So this is the splitting level given of the strong magnetic field. And how the energy level is given? Energy level is given, how the energy is calculated, that is ml plus 2ms, where ms is your I can explain you that s is equal to half, then ms is equal to your minus half and half. Okay, so this is your ms. L I have described, and what is ml you also know. Now you have to do the splitting. So when you will do the splitting of this, the table will become like this: ml ms, and here is the energy level, that is your ml plus 2ms. Okay, so ml is here 2, and here is half minus half because spin is, and for 1 half minus half, ml is 0 half minus half minus 1 half minus half, and this is minus 2 half minus half. And when will you apply the formula of ml plus 2ms, then you will get 3 1 2 0. Actually you have to apply 2 plus half, then 2 minus half, then that's why two values are coming. So you have 1 to do for half and 1 to do for minus half. Similarly here 1 minus half, 0 minus 2 minus 1 minus 3. Okay, so now you can see that 1 is repeating 2 times, minus 1 is repeating 2 times, 0 is repeating 2 times. So there are 3 doubly degenerate levels. Okay, so there are 3 doubly degenerate levels. So we can there are 3 doubly degenerate levels. Actually the formula is that if that how many, that now it will split, how many levels it will split. See, we know that ml plus, by applying this we will get 10 splitting levels. Okay, we will get 10. When you will apply L, when you apply S, you will get the answer 10. You will get the answer 10. But there are 3 doubly degenerate, so there will be 10 minus 3. So final splitting, so final in 7 levels. Okay, so this is, you have to keep in mind that the formula you have to minus from the your total splitting if any state is doubly degenerate. So there are 3 doubly degenerate, so your answer will be here 3. Okay, so answer will be here 3. So this is how you have to perform this. So now we can move to our next question. Our next question says, for a complex variable z and contour, this is mod of z equal to 1 taken in the counterclockwise. Okay, so now this question I can do here. I have space left. See now what you can do for here, you have to calculate this. So you can if you know the method of this, that how you can calculate first poles, then we have to denominator is equal to 0, then we get z equal to 0 and z square is equal to 0, and your this radius is 1, so both are lying in the your this contour. Okay, so now you can apply your formula z fz limit z tends to 0. Okay, so 1 upon 2 pi into formula of residues. This is the formula of residues. Formula of residues is 2 pi into sum of residues. Sum of residues. To calculate the integral, so you have to formula 2 pi into sum of residues. So 2 pi into sum of residues. Now we have to calculate your residue. So how you can calculate is, you can calculate with the simple formula, that is your zfz. So what is zfz? Now z is this and your fz is this. This is your fz. Okay, fz is this. So I am not here that putting 1 upon 2 pi, simply fz, then we'll get z minus 2 upon z plus 3 upon z square. Okay, 3 upon z square. So when you will take this, you can take common z upon z, it will become z square minus 2 upon z plus 3 upon z. So z will cancel, and when you will apply z limit, z tends to 0, then you will only left with minus 2. So now your answer will become 1 upon 2 pi, that is attached with your sum, into 2 pi into sum of residue. Sum of residues is minus 2. So this will cancel, so you will get minus 2. So here the answer will be minus 2. So the answer is minus 2. Okay, so now what we have to do, we can now go to question number your 20. So I can mark the questions I have done. We have done 21, 22, 23 also. 23 I am doing, 22 is being done. Okay, so now let P be the conjugate momentum if the transformation. So you have to get canonical for this sum. It is very easy. What you have to apply the formula of conjugate, that is your QP is equal to, this is capital, this is equal to PQ, which will be equal to del Q curly P curly P by curly Q minus sorry, I am writing this is first Q should come. We have to maintain the order. So formula in curly Q by curly Q, curly P by curly P minus curly Q by curly P, curly P by curly Q is equal to 1. So this is the formula of your canonical. Okay, so now by when you will solve this, you can solve it in your copy. I'm here doing only, like, if you will solve this, then what you will get, first curly by curly Q. Okay, so we have to apply, Q is given under root 2 QM cos P curly P under root 2 QM sin P minus curly by curly P, Q is under root 2 QM cos P under root, sorry, curly by curly Q, P is under root 2 QM sin P. Okay, so when you will apply this, what you will get, 2M you will get 2 QM minus 1 minus sin square P minus 2 minus 2, you will get also M here, M QM minus 1, and it will be minus cos square P. Okay, so when you will solve this, you will get 2M 2M minus 1 equal to 1. So you can now compare this, and you will get 2M minus 1 equal to 0. Okay, 0. So you can get 2M is equal to 1. So m equal to 1 divided by 2. So you will get answer here 1 1 divided by 2. So we have done this sum also. So now we will move to our next sum, that is your question number 25. If a particle is moving along a sinusoidal curve, the number of degrees of freedom of the particle. Okay, so now you have to calculate the number of degrees of freedom. So sinusoidal curve is given by y equal to a sine kx. Okay, so now here z equal to 0, so we have only left with y x, but here is a constant, that is it is defined by this equation. So number of degrees will be 1. So number of degrees will be 1. Okay, so now we will move to our next question, that is question number 27, that you are given the three eigenstates, and you have to tell that which one of the following option is correct. So for this type of sum you can do like this to mostly this type of sums I've seen in most cases from past experience, that your answer is from linear dependent or linearly independent. Okay, this is from my past experience, that you can guess for this answer. So you have to check for linear dependent or linear independent. So we can check this by formula u1 u2 u3 and v1 v2 v3 w1 w2 w3, where these are the vectors. Okay, so you can this is your u, and this is u1 u2 u3, this is u1 u2 u3, this is v1 v2 v3. So this is your w1 w2 and this is your w3. So you can apply here 1 0 0 1 1 0 1 1 1. Clearly it says that it is not equal to 0. So whenever it is not equal to 0, it is linearly independent set. When it equal to 0, then it is linearly dependent set. So any linearly independent set can be expressed as basis. Basis means that you can expand psi in terms of phi c1 phi 1 plus c2 phi 2 plus c3 phi 3 up to cn phi n. Okay, so you can do this. No, and this is the meaning of your basis. So now you can clearly see that the answer is your answer number C. Answer number C is your correct answer. Okay, so this is your C. Now we will move to our next question, that is question number 31. So now you have given your Lagrangian. Okay, so now how can you solve this question? Now see, Lagrangian is given alpha x dot square plus by dot square. So you have to calculate L is form of q dot and t, this form, this is q dot. H is in the form of p. Okay, so you have to change in this. So what is the conversion formula in Lagrangian into you have to calculate Hamiltonian. So formula is pk qk dot minus L. Okay, so you have to calculate first this in form of momentum. This is the form of q dot coordinate. Okay, so you have to calculate this. So what you can do, you can apply the formula, okay, to convert this. You can convert this. So the formula is del L upon del q dot. Okay, so when you will apply this, so it will become px, for px, del L upon del x dot, and also py is equal to curly L upon curly y dot. So when you will apply this, you will get 2 alpha x dot plus this is your px, and when you will apply for py, you will get 2by dot. So from here you can calculate x dot, which is your px upon 2 alpha, and your this y dot is equal to py by dot 2b. Okay, so you have calculated this. Now you can apply the formula. H is equal to now see, you have applied the formula. The formula will become px qx plus py, this is x, this is py qy dot, okay, minus L. So when you apply this, p remains p because you have to change in the momentum. Q dot qx dot will become px square by 2 alpha. So now plus py is py, and q dot is py square upon 2b equal minus bracket Lagrangian is alpha x dot. You have to change x dot also, because Lagrangian is in coordinate q dot, and Hamiltonian is in momentum. So you have to change q dot again x dot. So x dot we have calculated, that is px upon 2 alpha plus b, and that your this is Lx dot square, so it will become this will become x dot square, so it become 4 alpha square plus b, okay, p y dot square, it will become py square upon 4b square. Okay, so now you can solve this. It will become p square by 2 alpha. Obviously we have minus minus, so it will become, I can put the bracket, and this will become cxy. Okay, so now p square plus py square upon 2b minus px square upon 4 alpha minus py square upon 4b. Okay, this will become minus 6xy. Okay, so now we will solve p square this. You will get, we can solve this, and you can take common px square. This is also px, this is also px, so px square upon alpha is common, so 1 upon 2 minus 1 upon 4, which will become 2, so it will become 1 by 4. So px square by 4 alpha. Similarly for this, it will get py square upon 4b. Okay, 4b. Okay, so here will become minus cxy, minus cxy. So answer is your A. So answer is your A. That is, I have done correctly. I think it is 2 upon 8 upon 4. Yeah, it is correct. So your answer is your A. So it is very similar. What you have to remember is the formula. And in GATE, many questions are of this type. of see, from my past experience I can tell you the mainly questions of classical mechanics is on relativity, one question on relativity, one question on Lagrangian to Hamilton, Hamilton to Lagrangian, one question on your canonical or Poisson brackets. Okay, so and your that one central force is also a very important one, and next very important topic is your rigid body dynamics is also very important. So mainly questions are from this topic, these topics only. Okay, so you can practice these questions now. I can highlight this even because you will apply this formula to calculate P. Okay, so this is the formula. So question we have done this, question number 31 is also done. Now we'll move to question number 32. Okay, so what question number 32 says? Question number 32 says that you have to tell that which one of them is not your what I say, this is not rotational matrix. Okay, so to do this type of sum, the concept of rotation matrix is that determinant of every rotation matrix should be 1. Determinant of every matrix should be 1. I can write here with red that determinant rotation matrix is 1. It is orthogonal matrix. It is what is orthogonal matrix? That A is equal to your A transpose. A is equal to A transpose. So you can check this, and when you will do this, that is minus sin square theta plus cos square theta, this is 1, so this is not the answer. So cos square theta plus sin square theta, this is also 1, and next this will come sin square theta minus plus, so it is also will become, this will become minus sin square theta minus and this one plus cos square theta, so it will not become, so the answer is this, so the answer is D. So the answer is D. Okay, so this is very easy question. So now we can move to question number your 39. Question number 39 we can solve. Okay, so now this is also classical mechanics question. The concept of this is that omega is equal to under root k by m. You have given the angular frequency. Actually, you have to tell the angular frequency. So angular frequency is given by omega is equal to under root k by m, and you have to calculate k is equal to d square v by dx square, where x is equal to stable point. Stable point, x is equal to your stable point. So now if you calculate k from here, this is your v, or you can say u. So when you will calculate this is equal to d square v by dx square, you have to calculate it is x is equal to 0. So this is your stable point. This is your stable point. So now you can solve this alpha sin k square x. So alpha square k square will be out, and what it will become, cos k square x minus pi by 2, one time differentiation. Next time I will solve, so I will get alpha k4 minus sin k square x minus pi by 2. So now what you can get, you have to calculate x is equal to 0. So when you put, you will get minus alpha k by 4 sine of minus theta is equal to minus sine theta. So it will become 1, sine pi by 2 is 1. So it will become alpha k4, and when you put in this formula, omega is equal to alpha k4 upon m. So you will get k square is outside, k square is outside, and you will get alpha upon m. So your answer is B. So alpha k4 sine k square x minus pi by 2, and when you differentiate you will get alpha k4, x is equal to 0. So you will get sine minus pi by 2, sine of minus theta is equal to minus sine theta, minus will become plus alpha k4, and when you will put in the formula, so your k will become your that alpha k4. So k4 under root is k square under root alpha by m. So your answer is B. Okay. So now question number, this we also have done. So now question number 40 we have to do. See, this is the radial wave function you have given. You have to tell the alpha gamma alpha is the most what is the most probable distance. Firstly, clear the concept that most probable distance is your d p r by your dr equal to 0. Okay, so this is your most probable state. First you have to know the PR, that is radial probability density. So radial probability density is given by r square into r, or you can calculate also from P r is equal to PR is equal to 0 to pi 0 to 2 pi your psi star psi r square sine theta d theta d phi. So you can also calculate from here also and from here also. Okay, so when I'll calculate from here, I will get r square into r a r by alpha e minus r by 2a. Okay, so now you can okay, I first calculate from this method because I think it is first we will calculate from this method, then we will go to our shortcut method. Okay, so now what you will get, what is 0 pi 0 2 pi r square sine theta d theta d phi will become 4 pi. This will become 4 pi, and when you will solve this will become r square psi star psi will become, I will leave the constant, so it will become psi star will become r square e minus r by a. R square psi square will become 4 that is your r square. So what will become 4 pi into r4 e minus r by a. So now this is your PR, so now what we can do, now we have to do dpr by dr is equal to 0. Okay, so we have to do this. So now performing this, now see, check the answer that I'm confused. 4 pi is your from sine theta d theta d phi 4 pi, and from r square it is r square. Okay, r square this one, and from this you will psi star psi will become r square, so it will become, yeah, this is right. Okay, so now we can perform this. so const I'm not here writing the constant. So when I will do differentiation r4 of this will become minus 1 by a e minus r by a plus e minus r by a. So it will become your r4, so it will become 4r cube. Okay, so is equal to 0, is equal to 0. So when I'll perform this, e minus r by a is equal to minus e minus r by a, 4 r cube. So minus minus will cancel, e minus this will also cancel, and this will also cancel. So it will become r by a is equal to r by a is equal to 4. So r is equal to 4 alpha. So the answer will become, when we'll compare this, so it will become gamma will become 4. So your answer is 4. See, this is very easy question. Actually you have to calculate the probable density. Okay, so now what I have done, I have first calculated PR, that is your radial probability density. Okay, so now you can also do it from that I have told previous formula that I have rubbed. So you can also try for go to that method also and solve the same question. Okay, so now we will move to our next question. Okay, so we have done this question also, 40. So actually you have see, this is the surface area, so you cannot do volume integral, that is a dv r square sine theta dr d theta d phi. So here will not be, here integration will not be with your r. So I have taken r is constant, r is constant, r is constant, so I've taken it outside. So this is your outside term I've taken. Okay, so take care of this, don't apply your dv, that is your r square sine theta d theta d phi. Okay, so now we can go for question number 43. So question number 43 says you are given the 4 vector, that is your u 4 vector, and one is Levis-Veta tensor. So you know that Levis-Veta tensor is your Levis-Veta tensor is your antisymmetric tensor, and your this 4 vector is your symmetric. So product of symmetric and antisymmetric will be 0. So product of antisymmetric and symmetric will be 0. Okay, so you can also check this, that the answer will be 0. So now what we can do, our next question. Actually this question requires lot of concepts, so I'm not explaining here the whole concept. What I'm telling you, that this is your antisymmetric tensor. You can check this, this is your antisymmetric tensor, and this is your symmetric, and this is your symmetric. So product of symmetric and antisymmetric tensor will be 0. Okay, so this question is also done. So now we will move to our question number your question number 47. Question number 47 we will do. So now moving to this question, I want to tell some basic for this, that you have to this is a sinusoidal wave, so it will be dependent upon time. So what you have to calculate, you will calculate EMF first, and from that EMF first you have to tell the first non-vanishing exponent, that is the power of omega, first non-vanishing power of omega. So for this we have to calculate first EMF. So before EMF, so I've tell you the concept. Here you can apply Ampere's law, that is your uh, B dot dl is equal to mu naught epsilon naught plus, sorry, I can write this again, B dot dl is equal to mu naught I enclosed plus mu naught epsilon naught jd ds. Okay, so what is your jd is equal to curly E by epsilon naught curly E by curly t, which is your displacement current. This is your displacement current. Okay, so here I enclosed will be 0, obviously, because there is no current flowing, because there is no current flowing. So conduction current, this is called conduction current, this is called conduction, there is no current enclosed, that so I enclosed will be 0, only we have left with this. Okay, so here we will apply integral p into 2 pi r is equal to mu naught epsilon naught, okay, curly E by curly t into pi r square. So first we have to calculate E. So first we have to calculate E. We know that V is equal to minus E dot dl. So you can do this. V is equal to ED. So now V is equal to ED. So now we can calculate your E. So E from here, E is equal to V upon D. So E equal to V naught cos omega t upon your D. D is your length, so I can write this. So now you can B into 2 pi r is equal to mu naught epsilon naught curly E by curly t. When you will do this, so it will become minus omega sine omega t, sine omega t. Okay, so when you will perform this with respect to t. Okay, so yeah, minus omega sine omega t, and if I'm not wrong, minus sign is there. Yeah, minus sign is there. So now what you have to do this, this is your curly E by curly t. Okay, now to calculate the EMF, so you know that now B is proportional to your omega sine omega t. So E is minus d phi by B dt and minus d by dt. So phi is so how you calculate the magnetic flux? Magnetic flux is calculated by the your magnetic induction into area. So this will become B into A. Here A is constant, B is varying because B is varying. So you can do this minus A dB by dt by dt, or also you can calculate from that formula, that I will tell you one more formula that you can calculate here EMF. Okay, so now what you can do, minus A dB by dt will be omega square cos omega t, cos omega t. So cos omega t cos omega t. Okay, so EMF is directly proportional to omega square cos omega t. So first non-vanishing term, cos of expansion of cos is 1 minus x square by 2 factorial plus x4 by 4 factorial plus minus x 6 upon 6 factorial. So here will be, what will become, it will become your cos omega t 1 minus omega t whole square upon 2 factorial plus omega t upon 4 factorial. So your your EMF is directly proportional to your first non-vanishing term is omega square. First non-vanishing omega square. So exponent it is 2. So here the answer will be 2. So answer will be 2 here. Okay. So yeah, the answer is correct. So 47 we have done. Now 48 sum we will do. Here it is a Fourier transformation, but I've did the space is not left. I think I can do it. Yeah, I can do it here. Okay, I can do it here. So uh, here you are asking about Fourier transformation. So Fourier transformation, whenever you will do Fourier transformation, you have to kept in mind that the formula that is, see, it is very easy question. It is very easy question. So now first you have to understand what is your that your fx, or the concept I will tell you, that expansion of fx fx is equal to given by a naught by 2 plus infinity n equal to 1 a n cos 2n pi x upon 2a plus bn sine 2n pi x upon 2a. So now for a0 calculation, that is the constant, you can do b minus a to b fx dx. Similarly bn, sorry, an first, sorry, an is equal to 2 b minus a to b fx cos 2n pi x upon b minus a your dx. Okay, so and similarly for bn, we can do, and bn will here will be sine, rest all will remain same. Okay, so now fx can be even odd. From seeing this function, we know that from seeing this function fx, we know that it is your what it is your odd function. Okay, so now x is an odd function, so obviously when you apply this formula, this is odd, and we know that if limits is symmetrical, fx dx, then 2 0 to a fx dx for even and equal to 0 for odd. So limits are symmetrical, so a0 will be 0 here, an will be also be 0 because this is even, this is your odd, sorry, cos is an even function, so odd even will be 0. Only you are left with bn, so you have to calculate bn. So how we'll calculate bn is equal to 2 b minus a is the your limits, that is from minus pi to pi, this is 2 pi minus pi 2 pi fx is x, and what here sine 2 n pi x upon your b minus a is your 2 pi dx 2 pi. So you will left, you can apply here what that is your integration by parts. It will become 1 upon pi and I can turn this is into 202 pi x sine nx dx. So when I'll apply this 2 upon pi, and when you will apply that integration by parts, so x, and this stage you should know integration by parts, I will not explain this. So minus cos n x upon n 0 to pi plus 1, and one in differentiation, so here it will become 1 by n sine n x upon n, and 0 to pi. So obviously from 0 to pi this will vanish, and we will left with 2 upon pi, and when apply limits it will become minus pi cos n pi upon n. So this will cancel and will be left with minus 2 upon n. Cos n pi is minus 1 n. Okay, so for n equal to 2 it is asking minus 2 upon 2 minus 1 2. So this will become minus 1. So it will become minus 1. So the answer is minus 1. So the A2 is your minus 1. Okay. So now we are doing our last question. I think video is very lengthy now, so I have to stop after this question. Hydrogen atom is in orbital angular momentum L and ml is given to L if L lies on a cone which makes a half angle 30 degree with respect to z axis. Okay, so what you have given, you have given L ml is equal to L. That means L is equal to L and ml is equal to L. So you know from that space quantization, actually this you can space quantization. So space quantization you from know cos theta is equal to ml divided by L plus 1. Okay, this is hydrogen atom. Actually what you can I can tell in detail when we will start with atomic and molecular physics. This is your orientation, you can say this is orientation. This is your if it is z, this is your mz values, z pointing in this direction. So this is your mz values, that like if it is ml, that is will be minus 2 minus 1 0 1 2. If it is your L is equal to 2, so you have to, so angle is your this 30 degree. One is the angle is of this orientation is 30 degree. So what you can do is 30 is equal to, sorry, cos 30 is equal to under root 3 by 2 under root cos, you have to do this first, under root 3, okay, by 2 is equal to ml is equal to L L plus 1, okay, under root 3 by 2 is equal to L under root L plus 1. I can take square, so L square L plus 1. So 3L plus 3 is equal to 4L. So 4L minus 3L is equal to 3. So it will become L equal to 3. So L value is 3. So L value is 3. So we have done this question also. So I think this is enough for this video. Obviously the video is very lengthy, so this video is up to here only. Now the next questions we will do in next video. So I hope you enjoyed the video, and if you have any comments or have any query, you can comment below it. I will surely answer this, and thank you very much.